goes round and round. When they are done, they close the remaining pipes, the ones that they used, and then they exit. So let's compile this program and see it running. All right, so ini, this is it. Basically, the parent starts the game, but the parent doesn't really print anything. Every process only prints when it gets something, okay? So first to get the number is A, says I got 20, I'm sending 19. B says I got 19, I'm sending 18, and so on and so forth until the game is over. So let's see if there are questions for this program. I'm waiting to see if people got it. Right, apparently everything is good. Is it? So notice the large number. Yep, good. No, notice the large number of close that we're using. There is no way around it, really. And let me prove that. Um, if we move some of these closings later on, maybe we get lazy and we simply say, you know what, let's just close everything at the end. The program may get stuck. Now, in the version of this node that is online, I had a bug. I was closing here the wrong pipes. It was pointless. And then it may be that this suggestion that would get the program stuck, it doesn't work, but we'll try it. So it says just move in process A the first 4 close calls near the last 2. Let's try it. Let's see if the program is stuck if we do that. But if that doesn't work, we'll move other ones. Something like that. Let me do it and then I'll explain it on the code. It's not necessarily easy to visualize. So the idea was move this stuff at the end. All right, we've done that. Compile, and when we run it, yeah, it gets stuck. You see, it doesn't end. The programs, if we get out of VI and check, you can see that the inis are still up. They haven't stopped. They're stuck. So let's look at the code and try to figure out why is this happening. Let me try to get all the code. I'm not sure I can fit the whole code on the screen. But basically, the last one to write was B. So B sent a value, right, of 0. So let's see the behavior. B sends a value of 0 and then tries to get something from A. A hasn't written anything. So this is when B writes a 0 here, this is the beginning of the end. Whoever reads the 0 should jump here and break and close things, right? So B writes the 0, A reads the 0, right? Reads the 0. Hold on, let me get my bearings here. Yeah, I think. Okay, so A reads the 0 and it just breaks. Okay? And when it breaks, it closes everything. Now comes the parent. No, the B. Wait. I'm wrong. I confused the whole damn thing. So B writes to the parent. So parent reads the 0 and it jumps out. It doesn't write anything. So as soon as the parent read a 0, the parent jumps out. It doesn't propagate the 0 in other pipes. So then how is A gonna stop? Because normally parent writes to A, and if A gets a 0, then A stops. But parent doesn't write anything. Parent says, you know what, I gotta stop, it's less than 0. So parent closes the pipes. While this is happening, P is waiting, and I think, Mortuary, you have it right with what you wrote here. So while that is happening, process A is waiting for data from the parent. This pipe is empty. Now the parent doesn't write anything in it. It simply closes it. So A should stop, noticing that there is nobody else left to write in its pipe. The parent closed it. However, because A itself did not close the writing end to this pipe, because it moved, right? You see this one. Because this hasn't happened, process A still believes that somebody may write, because itself is holding an open writing end. And then this read doesn't break. And because this read doesn't break, these are not closed. And because these are not closed, B is not stopping, because it's still waiting for something from A. And because these are not stopping, the parent is not stopping because it's waiting for them. And it's all stuck. Simply because A is kind of waiting for itself to close the pipe or write something, but that's not happening. So let's say what Mortuary asked, because parent would wait to read, but he would also be connected to close, but it's actually about A. So this proves that if you don't close things right, programs get stuck. And they get stuck because of that rule. However, that rule is really useful. Without that rule, you wouldn't know. You'd have to have a while here without that rule to keep trying to read something. You'd have to implement the waiting yourself, because there is no guarantee when you read that the other end actually wrote anything. So then you'd have to implement your own waiting with a while. They give the waiting is already done. You just need to know how to use it. And it's very pleasant to write this code. Imagine you'd have a while here checking if we read something, and if we didn't, then the question is, well, how much are we gonna add? Wait, the code becomes much more complex. But you need to respect the rule. You don't close this at the right time, things get stuck. So let's hear questions about this thing. In the meanwhile, I'll fix the code here. I'll move these things back up. Let's compile again and see if they... Yeah, now it doesn't get stuck. Can you transmit pipe? Oh, you want to send a pipe through a pipe? Not really. And when I say not really, is because you don't really have a pipe to transmit. All you have is pipe ends. You don't have a pipe, you have pipe ends. Oh, thank you for this question, William. No. The only way to communicate through pipes is if you inherit it. You cannot really pass a pipe to another program. So the pipe mechanism allows communication between processes, but is restrictive. You can only connect with between processes that have a parent who created the pipe. There is no way of passing it. For that, you have FIFO. But because I haven't reached FIFO for the other guys, the discussion went longer with them. I'm not going to start pipes today because that is the next piece that we have to tackle. So it's only, sorry, I'm not going to start FIFOs today. For today, it's only pipes. So let's see if there are other questions from anybody. If not, we will stop early so that I don't go further for you than for the others. Pipeception, right? It kind of sounds like that. That would be quite yeah, quite recursive. All right, so these concepts are not really easy. If you look at the rules, they are quite not so many. You've got this much, right? But they have side effects, and you need to understand the side effects and get used to working with them and using them. Now, just as a look ahead, these are pipes and processes in Unix. It's unlikely that you will use this in your career very much. But if you ever get to use Golang, which is a pretty hot language nowadays, they have channels. And those channels follow the exact same behavior as this. Same rules, same idea. So if you understand how to use this as a concept, not as an API, then you'll be fine with that. Is dynamically allocated memory shared between parents and children, or is it copied? Copied. When I say that a child is a copy of the parent, I mean the memory of the parent is copied. In truth, not the whole thing gets copied, only a piece of it. For instance, the parent's code is not duplicated because that won't change. So the source code stays the same. The constants in the parent, and when I say constants, I'm talking about this is a constant, right? That string is a constant. And these values are constant. These are also not copied because they will not change. What gets copied is the variable part, which means heap and stack. Do channels in Go still have the problem with the maybe not, because in the Go channels will not work necessarily with bytes, they will work with objects. So I think you're not going to be hit by that. But the problem with incomplete reads will surface when you do sockets. Now, even nowadays, even sockets are wrapped into frameworks, and they solve this issue. But every now and then, you may need to send bytes through sockets, and then you need to be aware of this. And the solution is to something called like a stubborn read. It's a little piece of code. I think I'll add it into a seminar. Uh, just so that you see how you can read you can insist on reading. Either you insist on reading for a number of seconds or for a number of trials. All right, let's see if there are other questions. If not, we will stop. Trying to see if there is anything I skipped by mistake. Yeah. One thing that I want to tell you, so I started saying these things are rather complex, and it's not something that you memorize. It's something that you use and you get used to programming with. And I will post some practice problems for pipes and processes and everything. But before I get to do that, my suggestion is that you take these programs here and you implement them yourself. Not copy paste, but look at them, understand what they are supposed to do, and then implement them without looking at the solution and make them work. It will be really worth it. This one is not going to be very hard. This one is going to be freaking difficult. But if you get this done, then I challenge you to do the same thing, but for any number of processes. So have this program get a command line argument and then create as many pipes and as many child processes and have an eeny, meeny, miny, mo happening among a group of n processes. That will push you a little farther. You can find this problem that I've just told you about, actually a solution to it, in one of the graduation exams. I don't know which one of them, but if you check online on the department webpage, you'll find their past subjects and solutions, and in one of them, you'll find the solution to what I've just told you. All right, let's see. Last question. If you make a pipe between parent and child, and then the child executes a different code, can you transmit the pipe? And no, you cannot. But you can have the child do something with those pipes. And the answer is down here, but I was overly optimistic. This is when we actually will get to play with those. But I'm not quite done writing this section. There is a little more to it with DAP and DAP2. So what we're getting at actually is not really sending the pipes to the child program, but rather manipulating the child program so that it uses the pipes and will end up implemented something like Bash does with the pipe with input-output redirection. What does Bash do to take the standard output of a program and pass it to another? And the answer is pipes and dupe. And you'll see that happening next time. All right. Okay, so Berzen says merge sort in different processes. Yes, you could do that. Absolutely. Um, just as long as you can aggregate things. But a merge sort in different processes actually implies that an initial process has all the data, right? I guess. I don't know. But yeah, merge sort can be done in different processes. All right, guys. Are there other questions? Normally, I should wait about 7 seconds for questions to pop up, but then there is the delay of my question to reaching you, which is about 5 seconds, so I have to count to 12. Unrelated, but you know anything about when will we come back to college? Well, I'm pretty sure it will happen this century, but other than that, what I have just noticed was this, and this is a place that I advise you to check. Also, the department webpage, we have here all this big link. So this is actually what our department decides. Uh, and here you find university level things which our department will follow. And here what it says is that face-to-face teaching is postponed until the emergency state is lifted. So we don't know, really. My I'm trying to come up with a way of doing the tests online somehow so that we don't leave it all for the end. I'll let you know in time about it. So yeah, triple M 07. sounds like 007, but not quite. Yeah, you'll be notified of how we do the tests ahead of time so that you have time to prepare. Also, will the lecture notes PDF will be updated? Yes, they have been updated this morning already, so you should be able to get almost everything that's here. And I am updating it. Not even seventh or eighth week. I keep adding because normally this would have been taught in class and it would be much more interactive, seeing what you understand and what you don't. Sort of trying to adapt the teaching to how you react, but that's not happening. So I'm writing them up and you'll have them with seminar material and lab material. All right. Anything else, guys? Counting to 12. Well, then I guess that's that. If there is nothing else, you guys have a great day. Stay at home, enjoy health. We'll hear each other next week. Bye bye.